Hello friends, today's topic is motion in one dimension. Now what do we mean by motion of a body? By the word motion of a body, we mean that a body, the coordinate system of a body, or coordinate, not system, the coordinates of a body keeps changing. With respect to who? With respect to some point called origin. That is, the distance of the body from the origin is either increasing or maybe decreasing, and then we say that this body is in motion. How can you say that this body is in motion? What is this coordinate system? What is the specific thing about the coordinate system? The coordinate system is assumed to be at rest. If this coordinate system is at rest, then the distance of the body keeps increasing or decreasing, and we say that the body is in motion. So first I need to identify whether this coordinate system or coordinate origin of the coordinate system is at rest. Now I look around in the room and tell me which one is at rest. Well, very obvious, this board is at rest. The wall is at rest. I am in motion. My pen, yes, it is moving, it is in motion. Why? Because my distance from the board or my distance from the wall is changing. But who told you? The wall is at rest. Earth itself is moving. The wall is attached to the earth. So the wall is also moving. In the whole big universe, everything is in motion. Therefore, we suggest or we conclude that there is nothing in the whole universe which is at absolute rest. Therefore, absolute motion is not possible. Then what? This is the idea which Einstein brought in when he was talking about theory of relativity. And he said that nothing is absolute and we move related to each other. Example. Say for example I am sitting inside a car and the car is moving on. With respect to the steering or the driver, my distance is not changing. With respect to the doors of the car or maybe seat of the car, my distance is not changing. So with respect to the car, I am at rest. But with respect to a tree outside, my distance is increasing or maybe decreasing. I am approaching a tree. In such a case, I am in motion with respect to the tree. So rest and motion are relative to each other. They are not absolute, but they are relative to each other. Then what is my definition of motion? A body is said to be in motion if its distance changes with respect to its immediate surrounding. My immediate surrounding, my board, and I am going to move with respect to my immediate surrounding. So my distance between me and the board keeps increasing. And therefore, I am in motion. Or it can be decreasing also. In that case also, I am in motion. Right? Next term is what do you mean by one-dimensional motion? Now, when we talk about a distance or a displacement, we always talk in terms of time. Now, of course, time is another than one dimension. The second dimension that we are concerned with is distance or displacement. So that is where it is going to change. So I have only one dimension, the dimension of length, that is changing with respect to time. And therefore we say it is motion in one dimension. Now what is distance? Distance is the length, actual length of the path traveled by a body from its initial to its final position. Say for example, I want to go from home to school. I can take this road and go to school. Right? So the length of the actual path that I traveled is called distance. And its unit is, of course, meter. SI unit. Of course, there is CGS unit, it is centimeter. Now, what is displacement? Displacement is the shortest distance between the initial and final position. So, this distance S is the displacement in this case. Displacement is S. What is its unit again? Of course, I am measuring length and therefore it is meter. Right? Now, of these two, this displacement has got a particular direction. I have to go from A to B and nothing else. And in case of a distance, I am going towards north, then coming down to south, and then moving towards east, and then again going towards north, and then coming back to south, a little bit of south, and then a little bit of east. Not east actually, maybe north of east, a little bit. So every time my distance is, direction of motion is changing, and as a result, this is called a scalar quantity. Distance is a scalar quantity and displacement is a vector quantity. Now, vector quantities are those which has got dimension as well as direction, which has got a magnitude as well as a direction. Distance only has a direction, a magnitude, it does not have any direction. Say for example, I am walking towards east from point O towards east and I move through 30 kilometers. What is the distance traveled? Just 30 kilometers. What is the displacement? We write 30 kilometer due east. So this is how things are. Now when I take a rate of change of distance, what do I get? We get a quantity called speed. So what is speed? Speed is defined as rate of change of distance. Of course, rate means time rate, so we can also write distance with time. Rate of change of distance with time is called speed. So what is speed? Speed is equal to distance by time. Now what is it? Is it a scalar or a vector? Distance is scalar, doesn't have any direction. Time is, of course, it has got magnitude but doesn't have any direction. So both are scalars, two scalar quantities. When divided by one divided by the other gives you scalar. So this is also a scalar quantity. Right? And what is its unit? Its unit is meter per second or meter second to the power minus 1. You can also write it like this. Then comes velocity. What is velocity? Rate of change of displacements. Rate of change of distance is speed. Rate of change of displacement is velocity. So we can write displacement by time. And of course, displacement is a vector quantity. So vector divided by scalar is a vector quantity. So velocity has a direction. What is its unit? Same unit. And that is meter per second, or as again meter second to the power minus 1. we need to know the differences between distance and displacement. What is the difference? Of course, you start off with the definition. First, distance is the actual length of the path traveled by a body. Displacement is the shortest distance from the initial to the final position. Distance is a scalar quantity. Displacement is a vector quantity. Distance of a moving body can never be zero. It has to have some magnitude. Displacement of a moving body can be positive, negative or zero. Distance traveled by a body is always greater than the displacement. You can see it now. The curved line, length of the curved line is much greater than the straight line. Right? So these are some of the differences. Similarly, I can also find the same type of differences between speed and velocity. First, it is the definition. Speed, the rate of change of distance with time is called speed. The rate of change of displacement with time is called velocity. Speed is a scalar quantity. Now, this is very easy to remember. S with S and V with V. Okay? So, speed is a scalar quantity, displacement is a vector quantity. Now, speed of a moving body can never be zero. Why? Because distance cannot be zero, as you should. Speed of a, or rather velocity of a moving body can be zero, negative or positive. So speed can only be positive. This can be positive, negative or zero. Same as distance displacement. And of course, speed of a body can be greater than or equal to velocity. Now, question arises, when can distance be equal to displacement or maybe speed equal to velocity? Any answer from you? Okay. I give you the answer. You must be here. This can only happen, they can be equal in either case, if the body moves along a straight line. So if I go from A to B, okay, along a straight line, then this is the distance covered and this of course is the displacement. Therefore, rate of change of distance and rate of change of displacement are same. So when a body is moving in a straight line, then speed of the body is equal to its velocity. Right? Now, let us go to a situation where the velocity of the body keeps changing. What do I call them? Let us see. The rate of change of velocity of a body is called acceleration. So what is acceleration? Is equal to change of velocity by time taken or change of time, whatever you want, in a given period, duration of time, whatever. Now, what is it? Is it scalar or vector? The answer is vector. Why? Change of velocity, this is a vector quantity. This is scalar. So vector by scalar gives you vector. So this is a vector quantity. Alright. What is its unit? Unit of velocity is meter per second, and in the denominator there is another second, so it is meter per second square. We write it as meter second to the power minus 2. So this happens to be the unit of acceleration. Now, when the change of velocity is positive, that means the velocity of a body keeps growing or increasing. Right? In such a case, change of velocity is positive, and we say change of velocity is positive. We say positive acceleration or simply acceleration. When change of velocity is negative, that means the velocity keeps going down. In that case, we call it negative acceleration or retardation, or in some cases we also call it deceleration. Deceleration. Okay? Deceleration. Now, what do you mean by change in velocity? So, if I do it mathematically, we can also write it here that change in velocity is, suppose initially the body starts with initial velocity u, v is the final velocity, and t is the time taken. So we can write v minus u, that is the change in velocity, by t. So this is my formula. A is equal to v minus u by t, and that is acceleration. This actually gives us a very interesting relationship. I'm just writing off this part. So when I cross multiply, at equals to v minus u, you take u to the other side, u plus at equals to v, or we write v is equal to u plus at. This happens to be our first equation of kinematics. Right? One more thing I would like to discuss is, we talked about one concept actually, acceleration, negative acceleration and positive acceleration. When this v is greater than u, then we call it positive acceleration. And suppose, for example, a body is moving with a plus 5 meter per second square as the positive acceleration. Right? If v is less than u, then what happens? We call it the negative acceleration. And say for example, it is only minus 3 meter per second square, which is same as plus 3 meter per second square in opposite direction. Let me explain this. Say for example, I said the acceleration is a vector quantity. Say for example, it is retarding due east. The body is moving towards east and the velocity is decreasing. In such case, it is going at minus 3 meter per second square. That means I can say it is increasing its speed in the opposite direction. Right? In case of velocity also the same thing. If I am moving with the velocity at 5 meter per second due east, so I am actually going at minus 5 meter per second due west. But particularly in case of acceleration, it's not just the direction, it is the change in velocity which matters the sign. In other words, when the velocity is decreasing, we generally say it is retardation. Say for example, acceleration due to gravity. When a body is dropped from a certain height, it drops with an acceleration. This acceleration is called acceleration due to gravity, and such a value is 9.8 meter per second square downward. If I am throwing it up, the body keeps decreasing in velocity, stops, ultimately stops. So initial velocity is more than the final velocity. In this case, it is a retardation, and also if you look at it direction wise, if this is plus, then this is also minus. So direction wise, it is also opposite. So this is how we come to know that direction of motion of the body, right? In case of a normal motion, that means non-accelerated motion, which I say velocity also. If you go to your earlier pages, we discussed velocity is equal to displacement by time. Now, in case of a non-accelerated motion, therefore, S is equal to V into T, which is for non-accelerated motion, okay, or uniform velocity. So for a body which is going at a uniform speed, distance is given by velocity, or rather displacement is given by velocity into time, or if I say distance, then it will be speed into time. Okay. Of course, this is in meters. This is meter per second into second, which gives you meter. Here again, if you look at it dimensionally, this is meter per second, this is meter per second, this is meter per second square into second. So 1 second gets cancelled. Dimensionally, this is also meter per second. Right? So we stop here for the time being. We'll take up equations of motion in our next video. Thank you.